Okay, guys, so for 2.2, we're skipping 2.1 because we actually did 2.1 in Unit 0. So we're starting with 2.2, which is patterns, and then we're only looking at linear functions. So we're going to be looking at patterns, and then we're going to determine if it's a linear function. We're going to write the equation for the linear function, which is something we have not done yet, and then we're going to graph the linear function. So right now, let's look at problem number 1 on the top. Here's what it says. In the diagram, what is the relationship between the number of rectangles, so we're looking at the number of rectangles, and the perimeter of the figure that they form? We are going to represent the relationship using a table. We're going to represent the relationship in words, so we're going to write out in words what's going on. We are going to actually write an equation for what's going on. And then at the very, very, very end, we're going to graph it. And all that space is on the paper for you, okay? So what I would like you guys to do really quick is turn to your books. We're on page 103 in the book. And let's read what they have as a definition before we get to problem 1. Do you guys remember these definitions? 103. We are on page 103. Okay, so here's what it says. In a relationship between variables, so I'm starting at the second sentence, the dependent variable changes in response to another variable, which is called the independent variable. Do these sound familiar to you guys? Yeah. Okay. Here's another way of putting it. Values of the independent variable are called inputs. Values of the dependent variable are called outputs. We actually talked about this too when we were doing our notebook page on independent and dependent variables. So the independent variable is the input, what we're putting into the equation. The dependent variable is the output. Okay? So then let's go back to our notes. In our notes, in this problem, look at the diagram. We have one rectangle, and then we can find the perimeter using the numbers that are given. And then we have 2 rectangles, and we can find the new perimeter. When we add 3 rectangles, we could find the next perimeter. And when we add 4 rectangles, we can find the next perimeter. What is going to be our independent quantity here? Rainier. 6 is not an independent quantity. Peyton. The number of rectangles is our independent quantity. So what does that make our dependent quantity or our output? The perimeter. So in our table, let's label that. So this first column is going to be the number of rectangles. And guys, do you remember what variable we give our input? X. So we're going to call that X. Our output is going to be the perimeter. And output has the variable Y. And then in the last column, I want us to write these as an ordered pair. And that's X comma Y. Okay. So we're just filling in the top of the table first. Okay, so let's fill out the table first for one rectangle. So X is 1. It's just one rectangle. Now with our perimeter, look at your diagram. If this side is 6, that means the other side is 6. And if this one is 1, that means this one is 1. How can we write the perimeter of all of that without having to do 6 plus 1 plus 6 plus 1? Alex, do you know?
6, 2, and 1, 2.
Yeah, that's right. So 2 times 6, so let's write out our work. 2 times 6, because we have 2 6s. And then with perimeter, what do? Add them, and that's going to be 2 times 1. And what does all of that come out to? 14. So our output was 14. So how would we write that as an ordered pair? 1 comma 14. Do you have to put it in parentheses?
Yes.
Yes, because it's a point on your graph. and the parentheses indicate that those 2 points go together, okay? I'm going to do the next one with you guys, and then I'm going to have you all fill out the table on your own. So the next one is for 2 rectangles. So my input is 2. Now, does the 6 side change at all? No, so that's going to be 2 times 6 plus 2 times, now look at our ones. I have 1 1 and a second 1. So how many actually is that? 2. So 2 times 2. What does that come out to? 16. 12 plus 4 is 16. So our ordered pair is going to be 1, 16. I mean, 2, 16. You guys, I did that last period too. 2, 16. Sorry. Okay, so will you finish the chart for 3 rectangles and 4 rectangles? So when we plug in 3 for the number of rectangles, that's 2 times 6 plus 2 times 3, right? That's 18, so we get 318, and then with 4 rectangles, we get 20. So how can we explain what is going on in words? Will you please turn to your neighbor and explain to them in words what's going on? So what was going on each time? In order to find the, 6 was the length. In order to find the length of each rectangle, we just multiplied 2 times 6 each time. But in our diagram, that never changed, right? But what was changing?
The width.
The width. And the width was changing by how many rectangles there were. There was 1 rectangle here, and then there were 2, and then there were 3, and then there were 4. So, and then we added them together. So let's write that in words. First, we multiplied, the number of rectangles by 2. To get the total width. And then we added 2 times 6, which was the total length. And that gave us the perimeter. Okay, so what we did was we multiplied the number of rectangles by 2. That's the 2 times 1, 2 times 2, 2 times 3, 2 times 4. And that was the total width. And then we added 2 times 6, this part, which was the total length. And all of that added together gave us the perimeter. Does that make sense? So in words, that's kind of what I'm looking for when I ask you to write it or explain it in words. So then the next thing we have to do is try and figure out an equation that represents this whole function. First of all, guys, we always write equations with what? There's variables. Our 2 variables are x and y, right? Where does the y come up? Look at our ordered pair. Our y's are 14, 16, 18, 20. Where do those show up? At the end or on the other side of the equal sign, right? In an equation, we always like to write it first, y equals. And then what did we do? How can we take what we did in words and rewrite it as an equation? The first part was that we multiplied the number of rectangles times 2. So how could we write that? 2x. X is the number of rectangles, right? And then what did we do? Add 2 times 6, or could we put plus 12? Same thing. Oh my gosh, what kind of equation is this? It's a linear function. You guys just wrote your very, very first linear equation from a table. So last part, let's graph it. Question, is this graph going to be linear or discrete? Continuous or discrete? Why discrete? We have ordered pairs. What else? What are we counting as our x's? Number of rectangles. Can you have 1.5 rectangles?
No.
No. Can we do 1 3/4 of a rectangle? No. We were only counting full rectangles, okay? So our x-axis, let's label it, was the number of rectangles. Our y-axis was the perimeter. Okay. Let's label our scale of our graph. You can really do whatever you want, but because we have so much room on the x-axis, I'm going to do every other one as a 1. So right here, I'm going to put a line and I'm going to label it 1. And then I'm going to do 2, 3, 4. And then even though we stop at 4, I'm going to draw 5 too. But we can stop there. Our x's, or I'm sorry, our y's go up a little bit higher, so I'm going to do every line is 2. So this one is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm going to go up to 24. Okay, so on the bottom, I did every other one was 1. Going along the y-axis, I did every one was 2, so that way we can fit everything in there. Okay, and then let's graph what we have. Our first ordered pair is 1, 14, so that's going to be here, and 14 is here. The next ordered pair was 2, 16, so that's going to be here. The next one is 3, 18. And then 4, 20. Guys, if we did 5 rectangles, what do you estimate the perimeter would be? 522. So let's graph that one just because. And then we leave it discrete because we are only counting whole rectangles, right? Not too bad? So now what I want you guys to do is, with the person sitting next to you, do problem 1 in your textbook on page 103. It's basically the exact same thing, but we're looking at triangles. So you are going to need to do a table, words, an equation, and a graph. So let me show you how I kind of organize this. So I'm going to put my table on the left, and we had 3 columns. And then there should be 4, 1, 2, 3, 4. I can do this. Okay, so there's my table. You need to write what's going on in words. You need to come up with an equation. And then give me a graph. And I know the graph might be kind of squished, just do the best you can, okay? So work with your new partner. If you are a loner, work with the people around you, turn around, behind you, whatever. And I'm going to give you guys, I'm going to see where you are in 5 minutes, okay? Okay, first of all, with our table, what is our input value? Number of triangles, and that's x. What is our output value? Perimeter, and that's y. And then the last column is x comma y, right? Ordered pair, whatever. Whatever you want to put. Okay, so let's do the first triangle. Our input value would be what? 1. And then we are, to find the perimeter, we are taking 3, and there's 2 3s. So what can we do? 2 times 3 plus, what's our base? 4. 4 times what? 1. And what did that come out to? 10. 10 or 110? 10.
1, 10.
And then the ordered pair is 1, 10. Good. Okay, when our triangles were 2, when we had 2 triangles, That's 2 times 3, that doesn't change, plus 4 times 2, and that gave us 2 comma what? 14. When our input was 3, we got 2 times 3 plus 4 times 3, and that became 3 comma 18. And then this one would be 4, and then it all comes out to what? 422. And then you just add, yeah. So, how would we explain that in words? What did you guys do in words? Chewy, what did you do?
Multiply all numbers by 4. Wrong. I got it.
Okay, we multiply. What are we multiplying by 4? The number of triangles. We're multiplying 1, 2, 3, 4. So multiply the number of triangles, and I'm using abbreviations right now, by 4. And then what did we do? Then we added what? 2 times 3, or 6, and that gave us to get the perimeter. Obviously, I would like you guys to use complete sentences, but I ran out of space. So, did anybody come up with the equation?
Oh, I did.
Aubrey, what'd you get?
Y equals 4x plus 2 times 3 or plus 6.
4x plus 6? Is that what you guys got?
Yeah.
Awesome. And then your graph should have been a discrete linear graph, right? Okay, I'm not going to draw it because we're running out of time. So the graph should have been a linear discrete graph, yes?
Yeah.
Okay, awesome. So let's take your 2.2 notes and turn them over. Oops, wrong one. We're going to do problem 2 really quick. Problem 2, we don't have to make a table. They actually give us the table. But let's read what the problem says. The table to the right shows the relationship between the number of photos, X, you have taken, so the number of photos is X, and the amount of memory, Y, in megabytes left on your camera's memory chip. Is this a linear function? Describe the relationship using words, an equation, and a graph. So let's take a look at the chart. We start with 0 photos, so that means there's nothing on the memory card, right? So how big is the memory card? 512 megabytes. When we take 1 photo, then we have 509 megabytes. When we take 2 photos, we have 506 megabytes. And then when we take 3 photos, we have 503 megabytes left. So what's happening every single time? It's decreasing by 3. So if we add 1 photo to our memory card, we subtract 3 megabytes, right? Okay, so then when I add another photo, I subtract 3 more megabytes, which means I subtracted how many total? 6. And when I add a third photo, I subtract 3 more megabytes, which means I've subtracted how many total? 9. Okay, let's think about this, guys. If 1 photo subtracts 3 megabytes, 2 photos subtract 6 megabytes, 3 photos subtract 9 megabytes, what are we multiplying the number of photos by? Every single time, Abe? Positive 3 or negative 3? Negative 3, because we're subtracting them, right? So what is going on here in words? The amount of memory left on the chip is, what do we start with? How much memory do we start with? 512. So it's 512 minus, because we're taking memory away, minus what? You can't use X in your words because we don't know what X is. It's 3 times, what is X? The number of photos. Okay, so the amount of memory total left on the chip is 512 minus 3 times the number of photos taken. What I want you guys to try right now, see if you can figure out what the equation then would be. Okay, Kelsey said y equals 512 minus 3x. Do you guys agree?
Yeah.
I agree. This is fabulous. Did anybody write it like this? Y equals negative 3x plus 512? Anybody? That's also correct. Same thing. I don't care which one you give me. Okay? Great. So then if we were to graph this, our x-axis would be the number of photos, right? Okay. I'm going to do the same thing that I did in the last one. I'm going to make every other one 1. So here's 1, here's 2, here's 3, 4, and then 5. And then the y-axis is the amount of memory left. And we have to put the measurement because we know what it is. That's megabytes. And then I'm going to show you guys a little trick for the graph. What do you notice about how much memory we have? It's a lot. So if we were to start counting at 0, we wouldn't hit 500 until like somewhere way up here, right? So do you know? So Abe says, can we start our graph at 500? Technically, we can, but we have to put a little notation on there. So along the y-axis, from 0, will you put a little squiggle line? Or not a squiggle, like a zigzag line? It means like fast forward. So this means everything between 0 and 500, but it's not relevant to our graph. So then we can start at 500 here. So this little zigzag just means that we kind of fast forwarded from 0 to 499, and then we're going to start here at 500. And then I'm just going to count by 1. So 501, 502, 503, 504, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's my graph. Okay, is this graph going to be discrete or continuous?
No, continuous. Yeah, you can't take half.
Alex, will you say that nice and loud for us?
You can't take half a photo.
You can't take half a photo, so it has to be discrete, right? Okay, so when we take 0 pictures, we have 512 megabytes on our memory card. When we take 1 picture, how much do we have? 509. When we take 2 pictures, how much do we have?
506.
506. When we take 3 pictures, we have 503. And then what would be your guess as to what we get with 4 pictures?
500.
500.
No, wouldn't it be 501?
No,
Oh,
because
wait.
we're subtracting 3 each time.
For some reason I thought it was 501,
No.
not 500.
Okay. Is this one linear?
Yeah.
Yes, it is linear. Okay, so that's a linear function as well. How do you guys feel about that stuff?
Yeah.